Hello everyone. This time I'm going to talk about how targeted proactive information search can be done with adaptive intelligent internet agents, or Aigents as we call them. My name is Anton Kolonin and that's my project. And what is the problem that we are trying to solve? People now are not capable to handle overflow of information available on the internet sites and in social networks. They waste a lot of time dealing with that. Information is getting late often enough or being lost at all. So-called targeted advertisements are based on personal information and preferences collected by search engines or social networks implicitly. So the targeting is not precise enough. Ads may be irrelevant and annoying. And there is a question: how to get necessary data timely and precisely, keeping the privacy and ownership in respect to the personal information and preferences. And you know, that's important in business activity and everyday life all the time. We suggest to solve this problem with automatic intelligent internet agents, or AI agents. They work on personal smartphones, tablets, or computers, on corporate servers, or in the cloud. They can learn user preferences implicitly from social network activity and internet search history, or they can be told about the preferences explicitly. They are capable to find new information and extract it from the web pages automatically as soon as it appears online. And potentially, they can adjust to user preferences on the fly by means of experiential learning. Who are we working for? What are the people that can benefit using our agents or AI agents? First of all, there are marketing specialists at small businesses and startups. They can use it for tracking for announcements and releases on sites of competitors, for monitoring company brand in the internet media. Then it can be used by small and one-person businesses relying on monitoring of offers on bulletin boards. It can be used for real-time discovery and capture of target offers on specific electronic bulletin boards specific to local geographical area or kind of business. It can be used by politicians and public relationship managers of small businesses and startups for reputation management, for tracking person or company good name mentioned in social or global media sources. Further, there are professionals, financial and stockbrokers in also one-person businesses or small companies or something between mid-range and small. They can use it for managing customized news indicators and triggers specific to the portfolios that they are dealing with. They can perform custom configuration of local and global news sources specific to the financial instruments that they are working for. It can be used for real-time black swan discovery, in addition to existing technical and fundamental analysis tools. Finally, it can be used for analysts, business and technology analysts, and trend watchers, for trend detection for specific subject domains and internet segments, for trend monitoring and hunting for pivot points in story developments. Let's see how our AI agents can be compared to alternative solutions provided by different vendors. Primarily, there are a lot of news aggregators like Feedly, News360, Fark, etc., which provide automatic news feeding given pre-configured channels. Unfortunately, they can't get news feed from arbitrary site like some local vendor or some local administration in some geographical area which can be important for a particular business. Also, information is not being extracted, so you can get the page, you need to analyze the page, you can't get the exact piece of information you need from that page. Another segment of alternative solutions are brand analytics systems for internet media like Brand24, BrandWatch, Brand Analytics, etc. that are doing monitoring of brand performance in entire internet. Unfortunately, because they need to monitor the huge amounts of data, the monitoring results can be not timely enough for some cases, and information can be delivered with delay. And also, these services of this kind are too expensive for one-person businesses and small companies. Further, there is a huge market of personal assistants like Google Now, Siri, Cortana, provided by top leading technology companies. These personal assistants provide proactive, predictive information, search, and recommendation. Unfortunately, they work for limited scope of functions and subjects, and area of expertise of these assistants can be expanded by user. Only the companies need to work on supplying specific functionality, which may be missed for particular business or particular professional need. Further, of course, there are social networks, which provide targeted content delivery across social media channels. They do personal profiling of people and they try to identify the preferences of people using the data they collect, but user barely can be very specific, and users are not capable to specify what they need precisely. And also, the social networks can't extract information that people need. Finally, there is a very nice service from Google which called Google Alerts. So you can set up automatic search for given specific queries. But unfortunately, again, these notifications or alerts from Google search engine can be not timely enough for very many cases for some specific subject domains and internet segments, because Google can't index every site and every topic often enough. And also, Google Alerts can't extract information and deliver extracted information to people. So our automatic intelligent internet AI agents, they can do around the clock news catch up. You can set it up to 1 hour, 2 hour, and then they can extract information from raw text. They are configurable for any combination of websites and subjects of interest, so you can monitor a very narrow segment of internet space and subjects represented on internet uh, specifically to your area of expertise and professional interests. Our AI agents are configurable and trainable by users. They can assure strict confidentiality, so you can store your data completely privately on your own smartphone or even in your corporate network. And of course, our AI agents are cheap. For instance, here is a sample of how it can look like. So we have mobile version of AI agent, which can be configured to collect some business information and technology information from Reuters website, then some information about some activity from one of the Russian astronomical sites, then currency exchange rates from Central Bank of Russian Federation, and weather news for a couple of Russian cities from the specific weather site. And for example, on the left, you can see the news tape or news feed from this kind of AI agent. Now you see not mobile version, that's the web browser version. So we see that today artificial intelligence system piloting a self-driving Google car could be considered the driver under federal law from Reuters. Then we see currency exchange rates for dollar, euro, and Russian ruble. Then we see weather in Moscow, Russia. It's getting warmer, and the great advance, IBM wants to treat seizures, treat brain problems in people, putting artificial brain implants and managing the illness. Let's go ahead. What are supported platforms? We support now mobile Android versions. We support, as we have seen, web versions, and we support desktops. We support Windows, Mac, Linux, and also we have chat interface. So using artificial agents language, which is very similar to simplified English or pidgin English, used by people who don't know English very well. Using this simple language, you can interact with AI agent. You can ask questions, tell information, you can train AI agent, you can extend its area of expertise, area of knowledgeability, and you can interact with it all all the time instead of using user interface. And on themselves, AI agents can interact one with another. So, for example, if your AI agent learned how to find some new things for you, and my AI agent have learned how to find some other things from me, they can exchange that information, and both of our AI agents can give more information or can provide more precise information to us humans, their users. How we achieve that? We follow approach to implementation of general intelligence suggested by Ben Girdle, and the definition is capability to reach complex goals in complex environments using limited resources. So if there is an intelligent being, artificial or natural, it can have some target goals which are beneficial to the existence of the being, and there are many different roads to reach these goals, and there are also different existential traits or just non-existential traits, like you can reach small and not very interesting goals and get some damage, little damage, not critical. You can get some very significant goal in close proximity to you, but there is a huge risk to get critical damage, or you can follow some long path to some very beneficial goal without of damage at all. And so any intelligent being is trying to find a strategy how to stay existing in this life, but get more benefits from this life. For example, biological intelligence. It is used for search for nutrition and reproduction opportunities given multiple physical traits and limited physical resources. So you see, say there is a rat and there is a labyrinth, and there are different goals represented by pieces of cheese, big pieces of cheese, small pieces of cheese. There are also other rats that can be used for pleasure and self-reproduction, and there are different treats. Small treats, like non-existential treats, like electricity that can hurt a little, or there is a trap which can be critical for existence. So again, any animal may have different strategy how to deal with this problem and how to find its way through the labyrinth. Same is true for our AI agents. So internet agent is used to search for the most valuable information found as quickly as possible, given limited computational resources. So say we have a smartphone and we don't want this smartphone to have battery discharged just in 1 hour. We want our smartphone work in few days, but still providing us with useful information. And there are a lot of pages, web pages, that can be searched for particular pieces of information. And only a fraction of these pages contain useful information, and only small pieces of these pages are actually contain information that we need. And along these different pages you can navigate through different ways, and some ways may be long, some ways may be short, and some ways may be slow, like there may be web pages that can have or websites that can have large response time, so it takes long time to load the page, so there can be timeout. You can just break your navigation on that page and not be able to follow further links, or there may be sites that are not available for certain period of time. So the agent or agent is able to find the optimal road to the target page and find the most valuable information. How it is done? Our approach is create link traversal scenarios, detect these link traversal scenarios, and replay the found link traversal scenarios. So we deal with contexts. We have starting text context and we have target text contexts. Each context is a bunch of words, sentences, and associations of words one with another. So a bunch of words and meanings of the words build the context. And at each vertex of this navigation or link traversal graph, there is a situation when an agent is faced with context which involves the page on itself and a context of this page, and also there are different links leading from this page to other pages, and each of the links is associated with its own text context. So the agent can make decision about the point where they are located right now, and make weighted decisions regarding which of the links they need to follow to get further along the navigation path, finding the required information. Further, we have developed the algorithm which actually contains or is built by two different algorithms. One algorithm is path tracker, which has input as starting point, goal, and path set, or set of paths over a series of contexts possibly leading to the goal from starting point. And the output of the algorithm is found goal context after the visiting some of the paths that they have in using some strategy. So if there is a success, then the found text context, found page is returned back to the agent, which can further deliver it to the user. And if there is no success, so if none of the known paths or scenarios are working for a given starting pages and for a given goal, then the execution control is given further to Pathfinder. And the Pathfinder is scenario detector as opposed to path tracker. So path tracker is scenario player and Pathfinder is scenario detector. So the Pathfinder has the input of the following: starting point and the goal or terminal context. And the output is the path set if found. So if there is a way to find some new path sets or scenarios leading from starting point to the terminal or target goal page, then this path set, there can be one path or two path alternative paths are returned, and the found goal context is returned as well. And if the found goal context is confirmed by user that that's the true finding, that's the good thing, then the agent potentially can get reward and then retain the knowledge about new path sets, so it can be then reused by path tracker in another attempt to find similar goal given similar starting point. Here are just few examples of how it works. For one example, we tried to apply our agents for search of offers for used cars on websites in Russia. Like if I want to buy used Subaru Forester car, I can use different websites in different cities, or in the same city there can be multiple sites, and on each site there is some original structure of links, and from the starting page I can do a certain number of clicks to get the final page where my Subaru Forester cars are represented. So having agent exposed to all these different sites, it can do some analysis, and from that information infer some generalized reduced scenario of textual context changes during the link traversals. Like the generalized or reduced scenario is starting from the very beginning, from the top website page. We choose either automobiles, or in Russian it's called light mobiles. Then they click to Subaru and they click on Forester, and well, we're at the target page. Another example that we tried to for this presentation is business intelligence task for searching for company management contacts on websites, and we took a bunch of top companies in robotics area, for example, and we have given the bunch of these sites to our AI agent, and they have found exhaustive set of paths or traversal scenarios from start page to target page, like click about and you are there, click management and you are there, or first you need to click about and then board of directors and then you are there, and so forth. And finally we have reduced the number of paths and the number of words or textual context that can be used for navigation. So what you need to click on the link with word about, and then you need to click on one of the link with words management, leadership, or board of directors, and you are at your destination. And then the AI agent extracts the information, but the ways how they extract the information, that's a matter of another presentation. And by the way, when the agent learn that information, they can compress it in some simple and compact form that can be read by person, so the people can understand the logic of AI agent that can be that was used to do the search, and so they can do that manually at some point. But what is the most important is that this compact representation of information represented in AI agent's language can be used to transfer from one AI agent to another. So our AI agents can learn and then can exchange with such patterns or such navigation patterns. So your AI agent can learn from my AI agent in terms of not experiential learning, but just uploading your experiences and reusing my life experience. And finally, our algorithm has multiple optimization parameters, and effectively these optimization parameters represent something like artificial psychology model of an AI agent. Like if you consider the right axis of this parameter space, on the right side there is an AI agent which is operating in exhaustive mode, or when that can be called perfectionism. So if they are given the task, they try to find the best solution. And after all, if you say you wanted them to find something about Subaru Forester, in 2 hours they send you just a couple hundred of different Subaru Forester models in your area, so you can spend your time choosing which model, which option is the best for you. That's one behavioral model. Another behavioral model on this axis is on the left, which is called top of mind. Like an AI agent just find something, spending as little time, spending few resources, but they just return the result quickly. So you get just 1 or 2 cars and then you make the choice. So if you don't have time to make a perfect choice, you can spend little time to make a quick choice, but the choice may be not perfect. And that's all for today, and thank you for attention. And if you want to try using our Aigents, then you can just go to aigents.com and do registration using either Google Plus or Facebook, or just doing registration using your email address. And also you can turn email notification on or off depending on whether you want to get all Aigent findings in your email inbox, or you want just to watch them in the news feed on the web interface. And also you can use our Android application to use it on your Android phone. So thank you again, and stay in touch, and bye.